A little bit of snow here several days ago. Expecting some more snow tonight and tomorrow. I'm going to move this tractor into the shop. We had a lot of rain after there we go. Alright, let's see if we can get this started here. It's cold out here today. Huh. I wonder if we're out of gas. We put some gas in it the other day when the guy that I bought it from put some gas in it, but it's acting like it's out. Yeah. What are those guys barking at? Birds. They sound like they're barking at the eagle. We have the eagle, the bald eagle here. There's a couple of them roost in the trees, and the dogs bark at them. Got to get some gas. What you guys doing, huh? No, don't go over there. Okay. Good boys, come here. That's my good puppies, my good boys. Okay. button. Get some of this ice so it doesn't make a big mess on the floor. Hey folks, welcome back to the shop. Frank here. I'm going to get started on my next project here. This is going to be an articulated dump tractor, dump truck, four-wheel drive, and I'm going to use these two Cub Cadets. The 109, which we started on last week, got running, only took, what, a spark plug, plug wire, clean the points, fuel line, and some fuel, and she fired right up. So we'll use that tractor for its rear end. The other tractor, the 149, just pulled in. It's 14 horsepower, has auxiliary hydraulic ports on the hydrostatic transmission, which we'll use for steering. It's about 600 psi, 1 or 2 GPM, so it's not, nearly enough to run like a backhoe or front end loader, which you'd want, at least 5 or 6 GPM at 2500 psi, which would take about 10 horsepower to create that much hydraulic power. But it has enough to operate a cylinder for steering, for example. It may even be sufficient for the dump bed. We'll see what we need for that, but we'll get there. Anyway, today's episode, we're going to tear these tractors down, get them down to the frame, start looking at what we have to work with. And the plan is to use the 149 rear end on the back of this new tractor, and the hydrostatic transmission on the 109 will be in the front. It'll be close coupled to the engine. The engine's going to stick out over the front a little bit, which is the way these are generally done. I'm not the first person to build a Cub Cadet articulated tractor. My methodology may or may not look like other people's, but it's what I've kind of decided to do and the way I'm going to do the articulation point, that sort of thing. So I'll draw you a little diagram here in a minute, and then we'll get started tearing into these two tractors. All right, so I'm no artist, so bear with me here. The basic arrangement here, there'll be an engine. We'll put the hydrostatic transmission here, couple it together. It's attached to a gearbox, a transaxle, and so we'll have a wheel here. Out of the back of this hydrostat, there's an auxiliary output shaft. Actually, it's the input shaft, which goes all the way through. So it runs at engine speed. We'll take a shaft off that. We'll put it through a pillow block bearing, self-aligning, so it'll be supported at both ends. The other end of this will be a CV joint. In line with the CV joint vertically will be the articulation point. So we'll have an upper plate. This will be framed together, and then a lower plate, and then a second couple plates will come off of that articulation point. So this is edge view. So this point here with these two pivots will allow the front of the tractor to turn right and left. At this point, I'm going to mount a four-wheel drive truck hub. So it'll bolt into a plate here, and then back on the back it'll have a bolt pattern. There's a hole through it. So the CV joint shaft will go through there. We're likely to put a bearing on there so that the output shaft from the CV joint can pivot right and left. And then the other side of this hub, basically a hub, will attach to the rear of the tractor and to another hydrostatic transmission, rear end, and wheel. So that's the plan. these two things will be pretty closely coupled. We'll come off the frame here with a seat up here and a steering wheel, and we'll have to manage how to do all that. So that's the plan. Maybe give you a little bigger view of the articulation point. So it'll be probably a curve, have a hole in it. We'll have a second one underneath with a hole in it, and we'll have a second plate come off of this as well. So probably be a curve and a second sheet come down. You'll have a lower one, go around that, come back, and then we'll have our hub. So these will be pinned. The shaft will run through the middle, CV joint in line with these two pivot points. This hub, which will have 4 bolts on one side, which you would have on a four-wheel drive front wheel of a four-wheel drive truck, and then have, I think this one is off a 2500, Ram 2500. So this has 8 bolts on the output, so we'll use 4 of those to bolt it to the back of the tractor. And so that's how we'll articulate. CV joint in there. We may wind up with another CV joint before we get to the second transmission back here, but it kind of gives you an idea of what we're thinking about. So we have 2 axes of rotation. You have this vertical axis that lets you turn right and left, and then you have this circular hub with a big bearing in it that lets you rotate or roll, and that allows the 2 degrees of freedom you need for an articulated point. You don't want a 3rd degree or it'll sag in the middle, right? So you don't have a pitch. So you have yaw and rotation or rolling, but no pitch capability. And that just, so these are structurally pretty strong points so that they support the weight of the tractor going up a hill or whatever. So they'll be pretty rigid, robust. 1/4 inch or 3/8 inch plate steel, big bearings, pretty good sized drive shaft. So that's how we're going to do the articulation. There'll also be a hydraulic cylinder here, which will connect to the front and the back and cause it to steer. So that'll be driven by the steering wheel. We have a hydraulic power steering valve to go on the steering system. Just got the hub, came today. I've got a couple of CV joints, and I've got the power steering valve, so I've got most of the major components I need to create the articulation point. We'll work out the geometry when we get to that stage. All right, that's where we're going. Taking off these electrical connections here, so All right, so that's a Phillips head. These are 5/16 bolts. That's not coming out. We'll get it in a minute. Usually these screws are tough to get out. All right. All right, so the construction setup here is an open differential in the back here, not unlike you would see in a small automobile. There's a reduction gear under this plate here, output shaft, rear output shaft on the hydrostatic transmission here, relief valves. These have our manual release valves. So you have to push these buttons in to push the tractor. The auxiliary hydraulic ports here and here with the hard lines that run to the lift valve. There's a spool valve operated by this lever here and a hydraulic cylinder that operates the lift mechanism. These tractors use a rag joint, a flexible rubber and fabric coupling disc in the drive line, and this one's pretty well worn. And of course there's a cooling fan that's supposed to be here to cool the transmission. The transmission has cooling fins on it to radiate heat. The trunnion, if you're into Cub Cadets, you hear people talk about the trunnion. This plate here operates the swash plate inside the hydrostat, and this trunnion is actually in pretty good condition. There's notches worn here and here where these plates can get caught, so it causes a little bit of inconsistency in operation of the hydrostat, but it's easy enough to just hit with a MIG welder and weld that up, file it square. You get that back in action. Not too much play in the linkage. So that's forward and that's reverse. And the spring here just cushions the operation so you don't have jerky motion. Wow. Look at this. I'll tell you, that's just caked with crap, greasy dirt. That's not that uncommon, actually. Let's get the tonneau cover off next. Okay, so this has a little leaf spring operated by this lever, which pushes down on the two buttons on the relief valves, allows you to push the tractor. The other tractor, the 149, this is missing. Pretty common to be broken there. You can see this whole thing is just caked with dirt. I mean, these were garden tractors. I mean, they weren't just lawnmowers. They had ground engaging equipment, plows, snow blowers, rototillers. And it was pretty common to get dirt like this accumulated on these things. Really needs to be pressure washed. Too bad it's 25 degrees out. It's actually got the fan. That's unusual too, to actually still have the fan. Perhaps the original flex disc. A little bit surprising. Yeah, the linkage is pretty well worn here. Come here. What you looking at, huh? You looking at that tractor? What about you? You want to see what's going on? Or is there something going on outside you want to tell me about? Huh? I heard a little bit of barking. What was that all about, huh? What was that all about? I have never had a steering wheel come off that easily. That's incredible. I'm just stunned. It's got anti-seize on it. Somebody's had this apart. What a bonus. That's one nice thing about these tractors is there's no metric. All right, there's a set screw under here. I would try to get a pry bar under that. Well, let's just see. Sometimes these are a real problem to get off, and sometimes they're pretty easy. Got a hole drilled in it right there. One of the things I've done is drill and tap this and use this bolt to push it off the shaft. It's splined to the shaft. Doesn't feel like it wants to come off very easily here. Since this is a zinc alloy, I believe, cast zinc alloy. All right, so I cut the head off a little 1/4-20 bolt, act as a spacer. All right, it's coming right off. I mean, you could spend a long time trying to get this off without damaging the dash, which is just fiberglass plastic. There we go. Okay. And you know, when you reassemble it, you can put a short one in there and cover up the hole. All right, we're getting there. This is all in order to get the dash off. Leaking there, the hose fuel line isn't leaking. That's good. That's the PTO clutch actuator. That's the choke cable. And the throttle cable. Ignition switch, PTO switch, so these are the hydraulic ports on the transmission for the lift. I'm going to mark this. This is the out port, and that's the in port. So with an O. And over here with an I. Just to keep it straight. I can tell because the spool valve has an in port, and so this is the one that goes to the in port on the spool valve. And just keep everything straight. All right, if I'm not mistaken, I've got everything disconnected. This will leave the steering column and the speed control lever there. Let's see what happens here. There we go. All right, folks, this is a good stopping point. We've got much of this Cub Cadet disassembled. It's all easy. I mean, it's 3 wrenches or 4 wrenches, 3/8, 7/16, half, 9/16. Well, 11/16 for the ports on the hydrostat, the hydraulic ports. These tractors are so easy to work on. We'll come back next week, clearing out the frame. We need to make room for the other transmission. Sit right behind the engine. So we'll come back next week working on that. Now, the stuff that's in the frame here, the steering system's going to come out. We won't need that. The hydrostat control mechanism will come out. We don't need that. There's, foot pedals and stuff. I don't know whether it's going to stay in or not. We'll see if it's in the way. Anything that's in between the frame here is probably going to be in the way, so likely to come out. When we get the two hydrostats in there, just a quick note, the two hydrostats, the front one and the rear one, will be connected by a flexible shaft, so the control plates will move in unison. You need to be careful about how you set that up so that the actuating radius is the same on both control plates. That is, the distance for the connection point on the control plate to the center line of the swash plate shaft is identical so that they move in unison. For example, a 1-inch movement of the flexible shaft will result in the same amount of movement on both control plates for the two hydrostats. It may sound Greek right now, but when we get there, you know, I'll show you how we do it. It's pretty straightforward. We're just getting started here. This episode is how to take apart a Cub Cadet. These tractors are so easy to work on. All right, so we'll come back. In the meantime, if you haven't seen some of the other build videos on the channel, I've got build videos for my motor grader, mini motor grader, built from a couple of Cub Cadets. The gator that I built actually before I did any YouTube stuff. It's a 6x4, 4-wheel drive, hydraulic dump bed, and use that around the property. It's kind of become my wife's potting bench, so it's real helpful for that. The mini bulldozer, the forklift, which is sitting here in the shop, and my butchie boy coming in. And the most recent thing was a bush hog. We built a bush hog, 4-foot bush hog, and built a Category 1 3-point hitch on the back of a gear drive Cub Cadet, a 128. So it added a hydraulic system to that tractor, pump and reservoir and everything. So you can look at that. And if you go back and look at any of those videos, that helps the channel immensely. So I encourage you, if you haven't seen any of those builds, to go binge watch them. And you'll see some of the same kind of stuff that we're doing here. Been thinking about an articulated tractor for a long time, and a lot of the folks watching this channel, and and I appreciate this, there is a core group of 1,500 or 2,000 folks that watch every video, and I really am appreciative of that. Thank you very much for doing that. Hit the thumbs up if you enjoy this kind of content. Hit the notification bell so you get notified when the next video comes out. If you want to share and with your friends that would appreciate this kind of content, that'd be wonderful. Leave me a comment. Tell me what you think so far. And we'll see you next week.